Okay, so today's lesson is all about congruent parts of congruent triangles are congruent. And we shorten that using CPCTC because, of course, nobody wants to write all that down every time. And the idea is very simple. It just means that if two triangles are congruent, then their pieces of the triangles are also congruent. So our objective today is to use CPCTC to prove parts of triangles are congruent. So we're going to start with two triangles that are congruent. And then once we're sure that they're congruent, we're going to say, okay, based on that, I know these two side lengths are congruent. Or based on that, I know these two angles are congruent. So this is abbreviated all the time. So when you see these long string of letters, CPCTC, you should be thinking congruent parts of congruent triangles are congruent. That should be in your notes. We use this as a reason, a justification for saying, side lengths are congruent or angles are congruent. So while we're using this, we're still going to be applying the side, side angle, angle side, or hypotenuse leg to start out with the congruent triangles. Once we know the triangles are congruent by using one of those five postulates or theorems, then we can use the reasoning CPCTC. So it's not uncommon when you're doing engineering or surveying or different things for construction that you have to measure distances across features, landscape features that are not easy to measure across. It could be something like a lake, and if there was a lake here, you wouldn't be able to walk across it to measure it. It could be, in this case, they're talking about a ravine. A ravine is like a dip in the land. If I think I think it's smaller than something like a canyon or or a gully. Maybe it would be another word for it. But what it is it's like a hole where you can't walk across it. So in this particular case, we can make a congruent triangle, and if we have a congruent triangle, then we can match the pieces up. So I'm gonna letter this C in the middle where they meet. I'll label it C, and then I'm gonna put D and E on this picture. And so you can see that I now have two congruent triangles. I have two triangles. I have to show they're congruent. So I have triangle ACB, and I want to figure out if it's congruent to this other triangle I made. So I got to look at the information I have. I do know that this length AC is congruent to CE. So I'm going to mark that on my picture. Tick, tick, right? And I also know that this length from B to D, that C bisects it. It cuts it into two equal parts. So this BC is going to be congruent to DC. So far I have two sides of each triangle are congruent to the other triangle. The last bit is I notice that this angle pair is a vertical angle pair. So I can see that they will be congruent. And so the theorem or postulate I'm going to use is the side angle side postulate. So let's see what we can say. So I'm going to say first of all that that AC side AC is going to be congruent to side EC, and really that's given because they're both the same length, right? And then I have BC, side BC is going to be the same as DC. So BC is congruent to side DC. And then I'm going to say angle ACB. So here it is, ACB. So I went the 10-mile side and then the 15-mile. So now I'm going to do the 10-mile side and the 15-mile side. So that's going to be congruent to angle ECD. And so this was given. That's the reason I can say that. This is, well, I guess I don't want to use that symbol. This is the reason for this is for vertical angles are congruent. And then what I can say now is what I wanted to say in the beginning. I'm going to say triangle ACB is congruent. So now how did I name this triangle? I did ACB, so 10 shared angle and then 15 here, so I'm going to do the 10 side first. ECD, okay? So triangle ACB is congruent to triangle ECD, and the reason is by side, angle, side, okay? And so now that I know that, I can say, okay, because of that, this length AB has to be the same as length ED. Now notice I'm naming that. I went from A, which is by the 10, okay, AB, so I'm going to start naming this from E, which is by the 10, to D. So I'm going to say, okay, then I know that AB, side AB, is congruent to side ED. And what does that mean? Well, that means the length AB, and well, actually, why? First of all, why is that true? CPCTC. Congruent parts of congruent triangles are congruent. And then I can say, well, okay, AB equals ED then, which equals 18. So it's 18 miles is that distance from A to B. Okay, so in this example, we want to show that this angle X, Y, angle X, Y, W is congruent to angle Z, Y, W. So I'll just highlight those for a second. I'll show that this angle is the same as this angle. So our strategy is going to be that we're going to show that this triangle YXW is congruent to YZW. And then once I say that, I can use congruent parts of congruent triangles are congruent. And so let's see what we know about this picture. So I'm going to mark some things using tick marks, etc. So the first thing it tells us is that up above here it says YW bisects XZ. So YW bisects XZ. So that means that this length XW is going to be congruent to ZW because the segment is bisected, and the word bisect means cut into two congruent parts. So we know that. We also know that side XY is congruent to side YZ. So XY is the same length or same size as YZ. So I'm going to mark that on our picture. So we use 2 tick marks for that information. And then notice that these 2 triangles also share a side. So I know that that side is in both triangles, and of course it's the same size as itself. So I'm going to put 3 tick marks there. So we know by the side that this triangle, these 2 triangles are congruent. So we can say triangle YXW is congruent to triangle YZW by side. Now let's list our reasonings down here because we talked them through, but we should be able to list them out. So I'm going to list all our reasons. So we have first of all we have XY was congruent to YZ, and we knew that because they told us it was given. Then we also know that the next part that we looked at, this with the 2 tick marks, that was one we marked with 2 tick marks, but we also know that YW bisects xz. And so that gave us, allowed us to conclude that xw was congruent to zw, because that's what bisect means. Okay, so definition of bisect. All right. Then the third thing we have is we have this YW is congruent to YW. And that is the reflexive property of congruence. And so those are the three reasons that we were able to use side, side, side. We made this conclusion that the triangles are congruent. And so then our last bit, we're going to say, okay, if our triangles are congruent, then I know that angle XYW is congruent to angle ZYW because CPCTC, corresponding parts of congruent triangles, are congruent. Okay, so we're going to start by marking this picture with what we know. And the first thing that they tell us in this picture is that side NO is parallel to side MP. So we're going to mark that in the picture with two little arrows. I know that this side is parallel to this side. What does that tell us? Well, if these two lines are parallel and they're cut by this transversal that goes from M to O, then we know that this angle right here, NOM, is going to be congruent to PMO. So we're going to mark that in our picture, and I'm going to mark that with green. So this angle is going to be congruent to this angle, and that follows directly from the parallel lines because these are alternate interior angles. And if the lines are parallel, alternate interior angles are congruent. Well, we also know, and I'll mark this in blue, that the angle N is congruent to angle P, and they've told us that. So it's not something conclusion that we've come to by looking at the picture. It's information that they've provided. So I'll put a double tick mark there. The last piece of information that we have is by looking at the picture. We notice that this segment MO is in both triangles, so I can mark it as being congruent to itself. So I don't know why I put 3. Let's put 1 there. And based on this, we can see that these two triangles that we marked are congruent because we have an angle. Actually, I'm going the wrong way. Angle and an angle and a side. So angle, angle, side. So by angle, angle, side, these two triangles are congruent. So what I'm going to do right now is write that information out on this slide, just what I just talked through, and then we'll come back and walk through. Okay, so I wrote down everything we talked through, and the first thing we talked about were these green angle pairs. We said because the line NO was parallel to MP, that these green angles were alternate interior angles, and therefore they are congruent. So angle NOM is congruent to angle PMO. Then for step 2, we're talking about the blue angles, and we know the blue angles are congruent because they told us that. So these angles are congruent. Then the third step was saying that, well, this shared side is the same length in both triangles, so MO is congruent to OM. These two lengths are the same because it's the same line segment. Therefore, we have the relationship that angle, angle, side proves that these two triangles are congruent. Now notice we still haven't proven what we want to prove yet, but we're at the first part here. All right. So what can we say based on that? Well, what we can say is that congruent parts of congruent triangles are congruent. And if I can show that this angle right here is congruent to this angle right here, then I can show that these two lines are parallel. So let's go to the next slide, and I will show you on there. Okay, so based on the information that we just proved, I know that angle NMO is going to be congruent to angle POM because they are corresponding parts of congruent triangles. Now I've extended these lines for the sides of this quadrilateral and then also the transversal just to emphasize that these are alternate interior angles for these for the transversal MO crossing the line NM and PO. So by the converse of the alternate interior angle theorem, I know that if I have alternate interior angles that are congruent, then I know that these two lines have to be parallel. And so I'm going to mark them as being parallel. So this line is parallel to this line. And so that's my conclusion, and that's what I wanted to show. So I can say, therefore, line MN, line segment MN is parallel to OP. And the reason is by the converse of the alternate interior angle theorem. Now I'm using the name for it, converse of alternate interior angle theorem, but it's perfectly good if you can say, well, because these alternate interior angles are congruent, this line MN has to be parallel to OP. Don't get hung up on the the names for things. You can just explain your reasoning, and that's good enough. Okay, so we can prove things in the coordinate plane using distance and slope sometimes. In this case, it's really easy to show by side that two triangles are congruent using the distance formula. And so if we look at the distance formula, so it's the change in y squared plus the change in x squared. Actually, I'm going to write that the other way around, just because change in x squared plus the change in y squared. Now, one thing that's true, and the reason I'm using this form of the distance formula is that if you have the same slope for a line segment, but also that it goes for the same distance. So it does not work. What I'm going to tell you does not work if you reduce the slope. But if you're counting the entire slope, the change in y and the change in x, if the change in y and the change in x is the same for both segments, then the distance is going to be the same. So I don't even have to calculate this entire value out. I just need to know it's the same. And so I can see that when I'm going from h to I, I'm going down to, the change in y is down to over 1 for the x. If that's the same for this triangle, down 2 over 1, then I know that this formula is going to give me the same answer. So I'm going to mark that as being congruent. So let's look at the next bit. So if I look at this segment G to I, I'm going up 2 over 3. From D to F, it's also up 2 over 3. So my change in X and my change in Y, it's going to be 2 squared plus 3 squared for both of them. It's got to give me the same answer. So I know that this side is congruent to this side. The last side of the triangle is from G to H, so I'm going up 1, 2, 3, 4 over 2. Up 1, 2, 3, 4 over 2. So when I put in 2 squared plus 4 squared, I'm going to get the same thing for both of these. So that side is also congruent. That pair of corresponding sides. And so based on that, I know by side, triangle GHI, so we said GHI is going to be congruent to DEF. All right. So what does that mean? Well, it means that if that is true, then this angle DEF, so DEF, which is this angle right here, corresponds to this angle GHI, and so they have to be congruent. So then I can say angle DEF is in fact congruent to angle GHI. Why? Because CPCTC, corresponding angles or corresponding parts of congruent triangles, are congruent.